Okay, this one is number 84. For some reason I wrote 86. Woo. Must be Monday. Title is Area of a Quadrilateral. And I know you know this, but I'm just going to remind you, area is the number of squares that fit inside a 2D figure. Area is the number of squares that fit inside a 2D figure. (2D) stands for two-dimensional. So here I'm going to draw a two-dimensional figure. And I'm going to say it's 2 inches on this side and 3 inches on that side. And then if I'm trying to figure out the area, I'm going to try to figure out how many squares fit inside. So this is 2, 1, 2, and this is 3, so 1, 2, 3. So I could divvy this up into a bunch of squares. So then you count the squares. 1, 2, 3, 4, 5, 6, right? Now, of course, usually we would just multiply 2 times 3, right? But sometimes when you multiply 2 times 3, you forget that what you're actually doing is counting the squares. So the area here is 6 because there are 6 squares fitting inside there. And the squares look like this. They are 1 inch on every side. So 1 inch, 1 inch, 1 inch, 1 inch. So this is a square that is one side on every side. And so it's called a square inch. So a square that is 1 inch on every side is called a square inch. But sometimes we don't write it out like this. Sometimes we just write it like this. IN with a little 2 above means square inch. It means a square that's 1 inch on every side. So this answer would be 6 square inches. Okay, then perimeter is the number of lines that fit on the outside of a 2D figure. Perimeter is the number of lines that fit on the outside of a 2D figure. So when I'm talking about lines, I'm talking about that, which is 1 inch. So let's go up here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 lines that would fit on the outside of this figure. So that means the perimeter is 10. And then each of those lines is called 1 inch. So it's 10 inches. Okay, so I know you know all of this, but I just know that sometimes we get a bunch of formulas and we just use the formulas, and then we forget what the formula is doing for us. Like on this problem, you would have just taken 2 times 3 and not thought about the fact that it was 6 squares inside there. So just trying to get you to take a step back and realize what the formula is doing for you. One more vocabulary word before we get into formulas. So a height, so that's H-E-I-G-H-T. A height is a line segment that makes a 90-degree angle with the base. A line segment that makes a 90-degree angle with the base. That's what a height is. All right, so now finally we're ready to get into formulas. So all of these formulas have to do with area. So the first one is for a parallelogram. So the formula I'm about to write down is the formula you use when you're trying to find the area of a parallelogram. And area is base times height. That's the formula for the area of a parallelogram. And then for a trapezoid, the area is 1/2 times base 1 plus base 2 times, this is 1/2 B1 plus B2. Now the reason I'm pausing here is we had this formula before. We did base 1 plus base 2 divided by 2. That was called the median. So when you have the median of a trapezoid, this is how you find it. So I could be calling this the median. And then you take the median and you multiply it times the height. And that's the area of a trapezoid. Okay, then for a rhombus, the area is 1/2 times D1 times D2. And the D1 and the D2 stand for the diagonals. And then last but not least, I'm going to give you the area formula for a triangle. Now, of course, a triangle is not a quadrilateral, so it really doesn't go on this note card. But since I'm giving you a bunch of area formulas, I just thought I'd include this one on this note card. Area of a triangle is 1/2 times base times height. Okay, that's it for the note card. Title of the paper is Polygons, Day 2. So we're going to look at number 1 here, and the directions say find the area. So our job on this problem is to find the area of this figure. What kind of a figure is it? Yes. It's got 4 sides. Good. So it's a quadrilateral. Awesome. What else? Yeah?
It's a rectangle.
It certainly looks like a rectangle. And yes, I'll confirm that that's a 90-degree angle. I probably should have marked it as a 90 because you can't go by the appearance of it. So yeah, this is a rectangle. What else? Yes? It's a parallelogram, right? Because it has 2 pair of opposite sides congruent. These 2 sides are congruent, and those 2 sides are congruent. So since it has 2 pair of opposite sides congruent, it's a parallelogram. That proves that it's a parallelogram. So since it's a parallelogram, we're going to use the formula for the area of the parallelogram. So base times height. So the base is 9.2. And what's the height? 4.5. Now you do have to be careful. A height is a line segment that makes a 90-degree angle with a base. We did say that that's a 90. So 4.5 is the height because it's making a 90-degree angle with the base. So you take 9.2 times 4.5. I don't happen to have my calculator up here. Did anybody multiply that yet? Thanks, Emma. Thank you. So 41.4 is the answer for the area. And then what would the label be? Mm-hmm.
Meters.
Meters is not correct.
Oh, I thought that 9.2 was
It is, yeah, the 9.2 is in meters. But this is not. It's okay. It's all good.
Oh, meters, is it just meters?
Yeah, because when you're finding area, you're counting the number of squares that fit inside, right? So when you get your answer, then it's the number of squares, not the number of lines. Good. Okay, what kind of a figure is this? Yes, Taylor? Parallelogram, right? Because it's got 2 pair of opposite sides that are congruent. So that means this side's parallel to that side, and this side's parallel. So this is a parallelogram, so same area formula. We're going to do base times height. The base is 12, for sure, because that's on the bottom, right? I mean, the base doesn't have to be on the bottom, but in this case, we'll use 12 as the base. Is 4 the height? No is the correct answer. Why is 4 not the height? Yeah. Because it is not making a 90-degree angle with the base. You see this angle here? It's not 90. So you have to be careful. By definition, and if the formula is going to work, the height has to make a 90-degree angle with the base. So taking 12 times 4 here to find the area would not work. Okay, so there is more information given in the problem. There's a dotted line and then a 90-degree angle, and that line is marked as 3. So 3 is the height, because 3 is making a 90-degree angle with the base. Okay, what kind of a figure is this? Yes? It is a parallelogram because it has two pair of opposite sides that are congruent. This side is the same as that side, and this side is the same as that side, so it's a parallelogram. So we could do base times height for the area. Yeah, it's also a rhombus because it has 4 equal sides. So we could do the formula for the area of a rhombus. So on this figure, both of these formulas would work. Now I'm going to pick this one because it's the new one, and because in the problem they gave us the diagonals. I didn't mark those yet. This diagonal is 21, and this diagonal is 17. So since they gave us the diagonals, I'm going to use the diagonal 1/2 times diagonal 1 times diagonal 2 formula. But it is a parallelogram, as Maddie pointed out. That's correct. So we could use the base times height formula for it as well. Okay, so the diagonal 1 is 21, the diagonal 2 is 17. So you just multiply those out, 1/2 times 21 times 17. And that comes out to 178.5. And on this one it was meters, so the area is square meters. So I'm almost embarrassed to ask this question, but what kind of a figure is this? It's a triangle, right? So since it's a triangle, we're going to use the formula for the area of a triangle. So that's 1/2 times base times height. The base is 14. What's the height? 8.1. Now, are you going to use 8.1 because that's the only other number in the problem? Or are you going to use 8.1 because it's actually the height? It's actually the height, right? Because this is making a 90-degree angle with the base. So 1/2 times 14 times 8.1. So 56.7 square yards. Okay, number 5, we got this figure here. What kind of figure is this? Good, it's a trapezoid because it has one pair of parallel sides. This side would never hit that side, but this side would hit this side eventually. So this just has one pair of parallel sides, so it's a trapezoid. So to find the area, we have to use the formula for area of a trapezoid. So that's 1/2 times base 1 plus base 2 times height. There should be a plus sign in here, I guess, yeah. So over here we got the formula for the area of a trapezoid. That's the one I'm using here. What are the bases? Yeah. 14 and 8. Now that's kind of weird, right? Because usually when you hear the word base, you think on the bottom. But the official definition of a trapezoid base is it's the two parallel sides. So 14 and 8 are the bases because those are the two parallel sides. And then the height has to make a 90-degree angle with the base. So here's the height because it's making a 90 with the 14 and the 8. So that's also kind of weird because the height is going side to side. Usually you think of height as up and down. But the official definition of height is it has to make a 90 with the base. So since 14 is the base, 6 is the height because it's making a 90 with it. All right, so then you just go from there. You do 14 plus 8 first because that's in parentheses. And then you just take 1/2 times 22 times 6. And you get 66 square centimeters. All right, there's the problem number 9.5. That's the one we're going to do next. And this time they tell you the area of the figure. This is the information in the problem. The area is 20 square inches. The height is 4. And one of the bases is 5. And they also tell you that it's a trapezoid. So they tell you the area of the trapezoid is 20. They say the height of the trapezoid is 4. One of the bases is 5. And then the question is, what is the length of the other base? So this is a trapezoid. So that means we're going to use the trapezoid formula. So where does the 4 go? Yeah. Yep. Then B1, of course, goes for B1. 1/2's just hanging out. Carry it down. Where does the 20 go? Yeah. Yeah, that's kind of weird. You're not used to putting a number in over here, right? But 20 is the area. So 20 goes in where the A is. And we don't know what base 2 is yet. So we're just going to carry that down and recopy the base 2. So same formula as over here, but over here we knew the 14, the 8, and the 6, so we could fill those in. Here we know the 5 and the 4, but we couldn't fill that in, but we could fill this in. That's kind of strange. All right, now over here we have 1, 2, 3. That's 3 numbers multiplied in a row. This number times that number times that number. When you have 3 numbers multiplied in a row, you can choose to multiply them in any order that you want. So I'm going to take the 1/2 times 4 first. So to get from this step to that step, I multiplied 1/2 times 4 and got 2. Okay, now how is this 2 attached? Is it 2 subtracted? 2 divided? What goes there? Yeah. Multiplication, right? 2 multiplied by 5 plus b. So how do you get rid of multiplication? Divide. So I'm going to divide by 2 on both sides to get rid of that multiplication. So that's going to give me 10. And then you subtract the 5 to get rid of the addition. So base 2 is also 5. So this is a trapezoid where both bases are 5. Everybody doing okay?